So this is going to be a pretty straightforward lecture. It is pretty much very much a speed run on, hey, here's the accelerometer, here's what's going on with it. The goal is we're going to create a small app, a maze app. It's going to be a single scene application. A lot of what you're going to see in here is, stuff if you were to build this out completely. I'm not too concerned about all of like the interactions. The big thing is that you have a plane to roll across, which is going to be a cube, and then you'll have a sphere that's going to be your accelerometer ball. And as long as that you are doing that fine, and the reset trigger is going to because you'll roll it off the scene and be easier just to have a big trigger to just reset the ball. I'm not too concerned about it being a maze. You can guys go back and make the maze later on. I'm not too concerned about that. I'm more concerned, can you get the ball? Can you reset the ball? So like this maze manager script, state of the game, tracks all of this, start game, end game, not that big a deal. The maze trigger script, this is basically, hey, what is it the goal? Is it true calls the end game on the maze, false will call reset on the ball. And then float, reset, delay, how long do you wait before calling the reset on the ball? So a lot of this is like if you were to build this out as a full application. My focus right now is that it's more the ultimately that, again, you're using accelerometer. Create a maze ball script on the ball, has a public reset to put the ball back, and then use the accelerometer to move the ball. So this is not going to show up in the lecture, but right now if you guys look at me for one moment. All right, so your accelerometer works in actual 3D space. But we're going to get as you turn, as I turn the phone, like right now, I'm going to get a 1 off of this, I believe the Z-axis off the phone. That's the axis. Because that's the orientation it's in. And if it was upside down, I'd get a -1. Because I'm flat on the X and Y, I should get around approximately a 0. But this is, my hand, so it's not going to be perfect. So you're going to see some values. One of the things I recommend is to basically, in Unity, basically put a string a string on your screen so you can see the value of the accelerometer. Pretty straightforward. We need to translate the 3D space that the actual 3D space the accelerometer is in into Unity's 3D screen space. To do how to map that, literally I'm giving you the code. It's basically the direction is equal to director 0. So start with giving it as 0 across the board. X, for our purposes, X is going to stay the same. Y is going to be 0 because we don't want it going up and down. So we're staying on that axis, and that allows us. That's the illusion. Like the ball is moving across the plane. That this is my the surface of my screen. So it's not going to go up and down in 3D space. So we're always going to keep it at a 0 on the Y. And then the Z is going to be the acceleration data dot Y. And they pretty much show basically the code that you need. Unenabled, undisable, update. Again, they're doing accelerometer as a device. So while they're using the VAR accelerometer, I would not actually write this code. Actually, I'm going to actually go in. Let's build. Let me see. It's file, save as, make new folder. Three. All right, so I'm going to use the prefab, so I can get rid of the tank. I can get rid of everything on the canvas. Let's go to UI text, and this is going to be So I need to make this with, I'll say 500 just to be on the safe side. Do 600. And make it centered on the bottom. For my purposes, I think Y, I think 200. Negative 250, 260. There we go. So I want this down relatively down here. So this is going to be the, we'll call it raw data. So I'm going to get my acceleration down and I'm going to plug it into that field right there. All right. Let's go ahead. Let's just create the 3D object, which is going to be the sphere. Let's go to the scene view and just make sure this is at 0, 0, 0. And I'll put the Y1. And there's the common assets. Input. Not that one I want. There we go. And I will make this a lovely orange so it shows up. If you go back to the soccer ball, do I have it here? No, I don't think I do. But if you remember the soccer ball, if you want to use the soccer ball as your object, that's perfectly fine. This is going to be our ball. So name it as such. And we're going to go to lab 3 and we will create new behavioral script, maze ball. So I'm going to use this arena just for right now, so I don't have to worry about going off. We'll worry. I mean, you've done triggers before. Ball rolls and trigger. Basically, you're going to look for the maze ball script. Manager, you've done that before. All right, so I'm going to just jump right in. And I'm going to be using Unity Engine input system. Using Unity Engine, actually not Unity Engine, it's going to be TM Pro. And that'll be the first thing that I'm going to do here is going to be a text Mesh Pro UGUI raw data field. So one of the things that they are suggesting unenabled. So they are suggesting unenable, on, disable. So we'll just put this right here. So they're saying enable the device. So this might, so again, they're saying unenable, on, disable, enable, disable device. Cool. On update, so again, the way I would then go about around would be the accelerometer. Come on. There we go. So again, pretty much straightforward. The one thing that I will do is the accelerometer is going to be a vector 3. Actually, I'm gonna just use Excel, lowercase a, Excel data. So set it to 0 just to have something here. The idea here is that the accelerometer data equal to, let's go look at so they're going for acceleration.read value. So acceleration.read value. And the first thing I'm going to do right away is I'm going to take that acceleration data. I'm going to do the Excel. What did I call it? Here's the raw data field. Raw data field text is going to be equal to the Excel data to string. So I'm going to push it right to the string right away. The one thing I do need to, on the accelerometer ball, I'm going to move it rigid body RB. So RB is equal to game object get component rigid body. I could, in theory, I mean, actually, let's go the opposite way. Rather than get component, we'll just add component. So we don't have to worry about adding it on the object. All right, so let's go back to the, so this is the code that I need right now. So the Excel data. So that's the change I needed to make. So this should be the direction that so literally what we can do. The other thing is what we'll do is this needs to be public. And we'll make a public float let's just do max. We'll say a max ball speed of 10. Public float ball push. This will get. Okay. So the idea here is only 1.5, just so that it's not 1. The idea is how fast are we going to push the ball? And what we can do now that we've got our direction, what we can do then is now our rigid, not rigid body, not RB, linear velocity is going to be equal to our direction times ball push rate. Actually, we're going to add to it. So this is something we can play with later on. This 1.pi could be very too much, but we're going to add the ball push rate like every frame. So this is actually probably 0.15 is probably my best. It's better, probably a better rate. The one thing that we want to do is make sure that, hey, if RB linear velocity dot magnitude is greater than the max ball speed, then this is just making sure that our ball's not going off at flying, will be equal to the max ball speed. Oh, take off the magnitude. Oh, max ball speed. Hold on. It's going to be dot normalized. There we go. My apologies. I'm going to drop this onto another line just so it's readable on the screen. This would not be on 2 lines. And if you, I'm going to make this clear. If you write this line like it is right now, and it's not on, like, ideally it should be looking like this. So if you write your code, that's supposed to be that where I've split it onto multiple lines so I can show you on the projector. Whereas you should have just written in one line because ideally, this line of code is going to be like something like that, or that on your screen. So there's no reason for you to to break it up. For you guys, I'm working on a much higher font size, so you can see on the projector and in the video. So this is why I'm doing stuff like this. So please write this on one line of code. That's what I'm saying. And that's really basically what you're doing. Is you're getting the accelerometer data. You're enabling, disabling it. This is pretty straightforward code. You're on start. You're getting that. Just so you have that information, make sure you have a vector3 starting location, quaternion, starting rotation. And let's just make sure we're doing this on start. Starting location is equal to game object transform.position. Starting rotation is equal to game object transform rotation. Again, let's just do the reset function. I'll do this up here. It makes more. No, I'll do it here. Public forward reset ball. RB linear velocity is going to be equal to 0. RB angular velocity. So making sure those velocities are 0. Again, game object transform dot position, starting location, game object dot transform dot. So that's basically what your reset ball is going to look like. Again, you've seen this. You did the soccer ball. So, all right, let's jump back to Unity. Here's the ball. Here is the maze ball. Raw data. Here we go. Set that right here so that we can set it to it. I'll save it. Let's go to my build profiles and get rid of lab 2. And let me grab my phone. Wow. All right, my phone's ready for debugging now. So now I can go to click and build and run. This will be the maze ball. So I'm starting with my phone flat on the desk with the screen up. So waiting for it to build at the moment. Still copying over to the device. That's good. Okay, so first things first, it's running and it's doing what I want. Um, the ball's super tiny. So if you're using this scene as it is, like this ball, we look at the game view, the ball's really tiny. So let's start with the ball. We'll make this twice double the size. I'm gonna move it up to. Let me just make sure. Let's see. I think just one. Yeah, that's close enough. Yeah. So if I want to be, crazy, I'll do 1.1. So it'll just be off the ground. It will fall just a little bit, which is not that which is negligible for our purposes. I actually may want to do 3. So 1.5. I'll do 1.6, just a little bit above. So 1/10 above. So basically half of the y plus 1/10. So that's why that's how I'm getting the 1.6. Yeah, this is just more just to be like, hey, looks nice. I think for the purposes of our argument right now, yeah, let's get rid of the floors. I mean, the walls, I should say. And then I'm gonna take the gray floor. Again, this is a box, so what we can do is duplicate this. And we're gonna grab this and put it down here. I'm gonna drop this, let's say 0.5. I'll make this 100. And I'm going to turn off its mesh renderer. Okay. So the goal here, and I'm going to make this, I want to make this actually not 0.5. I'll make this 10 units just so it's big. So minus 0.5 should be not 0.5, minus 5. I'll just do the whole, no, I'll do minus 6. So it's just below the surface. So this is and if you were really concerned, I mean, you could go 1,000 by 1,000. This is definitely, this will definitely catch the ball if something weird happens. Again, this is the close the general ball trigger. And this will do the new behavior script. Maze trigger. And I'm only going to write this for, I'm going to write this so that we're only dealing with, again, we can take all of this out. On trigger enter. Maze ball is equal to other game object. Get component and parent. I'm gonna make this a little bit smaller. If ball, again, we don't have to do if it's not equal to null because, and then we can do ball, reset ball. And I'm just going to basically, just because we know it's going to be later on, we might as well just put it in public bool is goal trigger. And we'll set that to false. Actually, we can do this right now since we have the bool. If is goal trigger we can just do return. Do later. Hook up to maze manager script. Do else. I'll do the else. So a little extra, you know, we'll do more work to do later on when you've got the maze manager script and all that other stuff going on. But here we go. We can save the maze trigger. Let's go back to the, make sure that box collider is trigger. We can collapse the mesh renderer. We can actually get rid of the mesh renderer. Well, I'm going to leave the mesh renderer on in case you want to turn it on. Again, if you really wanted to, make sure you have it like transparent. And then here's the maze trigger script. And I'm going to save the scene. And I'll do build and run. The text is small on my phone screen, so I could actually probably make that bigger. There we go. And it's doing its thing. And I definitely could give it a better and this is basically more of a matter of like how it's playing. You know, I could probably boost the maximum speed and boost how much the ball gets pushed when I via the accelerometer. So those are things that you can play with. So, any questions? Show of hands, you're all good. Waiting for one more.
Oh, I'm behind.
Okay.
I
Yeah.
was messing with computers because this one was slow. I was moving that one, then this one turned on again.
Okay. All right, I'm going to stop the recording here.